Hello everybody and welcome to STEM School. In this video, I'll be finishing the last topic about quadratic equations, where I'll be explaining what the discriminant is. This often gets asked in the exam, so I'll go over plenty of exam questions so you understand how to tackle these properly in the exam. And before I begin, please do remember to like the video and subscribe to the channel for more tutorials just like this. Okay, here we go. When it comes to solving quadratic equations, just like this, ax squared plus bx plus c is equal to 0. What we're doing is we're essentially solving this quadratic equation to find x, and there are a few methods to do just that. The first one you'll always try is factorising. So looking for common factors and factorising that into single or double bracket form. And I'll link a video explaining just that. But then sometimes, quadratic equations can't always be factorised. So in that case, what you do is you use something called the quadratic formula. And again, I'll explain, I'll link a video explaining just that. So we have x is equal to minus b plus or minus b squared minus 4ac in a square root all over 2a. So if we look at a graph of the quadratic, which is a parabola, right? So we have an xy graph just like that. So when you're solving a quadratic equation and you get values of x, you can get two values of x. So in that case, what you're doing is you're finding where the points where the curve intersects with the x-axis. So that's one scenario. Another scenario is you can get one value of x when you solve the quadratic equation, okay? And that will look something like this. With the parabola, it just touches the x-axis just like that, alright? Now, if we look at the quadratic formula, we have this square root here, and that's very important. So I'll write that here, b squared minus 4ac in a square root. So for this formula to actually work, we can only take the square root of a positive number. So that means the b squared minus 4ac is a very important number, and that's what we call the discriminant. So if we move down here, I've explained what the discriminant is. So we have the quadratic equation, ax squared plus bx plus c is equal to 0, and we have something called the discriminant. So when it comes to the roots of quadratic equations, sometimes we want to quickly know the nature of the roots you get from that quadratic equation, and that's where the discriminant comes in. So the scenario is you'll be given a quadratic equation, you'll be asked to describe the nature of the roots. So in that case, you use the discriminant. So there's different scenarios that you can get. You can get two real and distinct roots, you can get one real and equal root, and then you can get two real roots, just like that, okay? So that's describing the nature of the roots. So if we go down here, we can look at the different scenarios that we have. So the first scenario is where you have two real and distinct roots. So what does that look like? Well, what it looks like is just a parabola like this. So this is where the parabola intersects the x-axis at 2 points here. So we have two real and distinct roots. So this is a scenario that happens where the discriminant, right, the discriminant is equal to b squared minus 4ac. But to get two real and distinct roots, b squared minus 4ac has to be greater than 0. Okay, so that's the scenario you're looking for. Now, if we go down to the second one, what we have is one real and equal root. So what does that look like? That's where the parabola touches the x-axis just like this, okay? So for that to happen, what the discriminant will be, b squared minus 4ac has to be equal to 0, okay? So that's what you're looking for. So when you get the discriminant equal to 0, that's when you know the quadratic has one real and equal root. And the last scenario that we have is no real roots. So the parabola won't touch the x-axis at all. So it'll just float above or below somewhere. It won't intersect with the x-axis, alright? So how does the discriminant tell you that? So the discriminant, b squared minus 4ac, will be less than 0, okay? So when that happens, when you get given a quadratic equation, you use the discriminant formula, and if the number is less than 0, that's when you know the quadratic equation has no real roots, okay? So the type of questions that you get in exam, you'll get given a quadratic equation and they'll tell you to, describe the nature of the roots. So that's where you use the discriminant formula. And we'll move on to some exam questions next. So the questions that you get asked about the discriminant tend to be really straightforward. So what we'll do is we'll jump straight into some exam questions in. So this first question here, it's saying determine the nature of the roots of f of x is equal to 7x squared plus 5x minus 1. So the clue that is looking for you to talk about the discriminant is these keywords here, nature of the roots, and it gives you the quadratic equation. So what we do is, it's a simple process that we have to follow. What you do is you quickly write the quadratic equation first of all. So f of x is equal to 7x squared plus 5x minus 1. And then I advise you to label what a, b and c are so that you know the correct values to substitute into the discriminant equation. So we have a is equal to 7, b is equal to 5, and c is equal to minus 1. And then the next step is just to write the discriminant equation. So the discriminant equation is b squared minus 4ac, and then just substitute the values that you've identified. So we have 5 squared minus 4 times 7 times minus 1. Then when you compute that, what you'll get is 53. Alright, so for these types of questions, what you have to do is, after you work out the actual number value, you have to add a sentence, right? And that's your conclusion where you describe the nature of the roots. So we've identified that the discriminant is greater than 0, as we have 53. So since the discriminant is greater than 0, what we have is real and distinct roots. Real and distinct roots. So what does that look like? What we have here is basically just an xy graph. So we have y, then x, and then we just have a graph like that. So we have real and distinct roots, just like that. So that's basically the general idea of these types of questions. We can move on to the second question here. We have determine the nature of the roots of f of x is equal to 2x squared plus 4x plus 5. So again, we're looking to describe the nature of the roots. So we need to talk about the discriminant. So what we do is f of x is equal to 2x squared plus 4x plus 5. And then just quickly label what a, b and c are. So in this case, it will be a is equal to 2, b is equal to 4, and then c is equal to 5. Right? Then just write down the discriminant equation at this step. So it will be b squared minus 4ac. And then we just substitute the values in. So we have 4 squared minus 4 times 2 times 5. Just like that. And then what you'll compute is the discriminant is equal to minus 24. So we have a minus answer. So we've calculated the discriminant as being less than 0. So as our final sentence to talk about the nature of the roots, so what we do is, since the discriminant is less than 0, what we have is no real roots. No real roots, just like that. So what you have to do is just memorize the 3 different scenarios that you can get about the roots. So in this case, what we have is an xy graph, y and then x, and we've got like a parabola just like that. So it's not intersecting with the x-axis at all there. So yeah, it's just fairly straightforward. Just write the quadratic equation down, label what a, b and c are, then substitute those values correctly into the quadratic equation, and then always remember to add a conclusion, add a wee sentence at the end talking about your value of the discriminant and what that implies. What kind of roots do you have? Now this is the last type of question you can get about the discriminant. It's a tad more complex than the examples that we just completed, but I'll explain the process that you need to follow to tackle this, alright? So this question is saying we've defined the range of values of p such that the quadratic equation px squared minus 2x plus 3 is equal to 0, where p does not equal to 0 and the quadratic equation has no real roots. Right, so it's a tad more things that we have to take into consideration here. So what we have here is the scenario no real roots, right? So when it mentions no real roots, or it mentions real and equal roots, or it could mention real and distinct roots, that's also implying that we need to look at the discriminant, okay? And we've been given a quadratic equation, but in this case it's missing one of the values, one of the numbers. We've been given p. So what you actually have to do is just follow this procedure as normal, but in this case we have to consider the no real roots part. So when we have no real roots, that implies the discriminant has to be less than 0. So b squared minus 4ac, has to be less than 0. So you'll know that scenario that you've memorized from before. So we can work with this scenario and we can work with this quadratic equation to find the range of values of p to give us this scenario, alright? So what you do is follow the procedure as we did before. You write the quadratic equation yourself, so px squared minus 2x plus 3 is equal to 0. And then you identify a, b and c correctly to substitute into the discriminant equation just like before. So we have a is equal to p, then b is equal to minus 2, and then we have c is equal to 3. Okay, so now what we do is just write the discriminant equation. So we have b squared minus 4ac, and then let's just substitute these values in. So we have minus 2 all squared minus 4 times p times 3. So what does that give us? So minus 2 squared will be 4. They have minus 12p. Alright? So at this stage, we don't know what p is, right? So we can't get a value of discriminant. But what we do know is a scenario that this quadratic equation has no real roots. So the discriminant has to be less than 0. Okay? So what we can do at this stage is make it 4 minus 12p is less than 0. So we have this inequality here. So this is where the scenario that you've been given in the question comes into play. If the question said real and distinct roots, that's when you'll have greater than 0. Okay? But if the scenario was given as real and equal roots, then you have equal to 0. Okay? So just depending on what scenario you have, that's what you'll put at this stage of the question. Okay? So all we have to do is solve this inequality to find p. So we can take a common factor of 4 out. So we have 1 minus 3p in the brackets is less than 0. 4 times 1 is 4. 4 times minus 3p gives us a minus 12p over here. Alright, so let's keep going. We can divide both sides by 4, leaving us with 1 minus 3p is less than 0. Now, the unknown variable that we're trying to find, we tend to keep that on the left hand side, don't we? So let's take the 1 to the right hand side. So we have minus 3p is less than minus 1. Now, this is what I want to point out at this key stage here. So whenever you divide both sides of the equation by a negative number, that's when you have to reverse the inequality sign. So I'll link a previous video that I done explaining that in more depth, but you'll see in the next step what I mean. So I want to divide by negative 3, both sides, had to leave p by itself, so we have p. Now, if I divide by both sides by minus 3, then I have to reverse the inequality sign, so it'll be greater than this time. So we'll have minus 1 divided by minus 3. That will leave us with positive 1/3. And that's the final answer, as simple as that. So you just need to remember that key stage here. When you divide both sides of an inequality by a negative number, you reverse the inequality sign. Alright? So it's a simple process to follow. It just adds a little bit more steps at the beginning. Alright? So you need to look at what scenario you're given. So in this case, the quadratic equation has no real roots, and that will give us what to put in at this stage here. Okay, so that helps us find the range of values to complete this problem. Alright folks, so that's us completed this tutorial then, and if this video has helped you, please do remember to like the video and consider subscribing to the channel. That would be fantastic. And do join me in my next video where we'll start the lengths and angles topic, where I will be explaining the Pythagoras theorem. So I'll see you guys then.